equilibrium situation on inclined surface, rough. Sipo now applies a force to help his friend Melissa in the wheelchair to move up a similar ramp of length 10 meters and a vertical height of 1,5 meters as shown. The combined mass of his friend and the wheelchair is 60 kilograms. But this ramp is not frictionless. The frictional force between the wheels of the wheelchair and the surface of the ramp is 50 newtons. The rotational effects of the wheels of the wheelchair may be ignored. Determine the force applied by Sipo if he moves the wheelchair at a constant velocity. Solution. Before we proceed, let us identify the situation. The surface is inclined. It is a rough surface. The wheelchair is in equilibrium state since it is moving at constant velocity. Let us find the forces acting on the wheelchair and draw its free body diagram. The force of gravity Fg is acting in the downward direction. The normal force acts perpendicular to the contact surface, that is, the plane of the incline. Again, the angle theta at the bottom of the incline is the same as the angle made by Fg with the normal to the incline. The force of gravity Fg can again be resolved into the two components, the one acting perpendicular to the slope and the other acting parallel to the slope. The plane of motion is along the inclined surface, so the net force in a direction perpendicular to the inclined plane is 0. The component of Fg parallel to the incline, Fgx, will pull the wheelchair down. Therefore, there must be a force applied by Sipo in the opposite direction. A frictional force F opposes the motion of the wheelchair up the incline. That completes our free body diagram. We can apply Newton's second law to the motion of the wheelchair along the incline. Vector Frx equals m vector Ax. Vector Frx is the vector sum of the forces along the incline. Therefore, vector Frx equals F applied plus vector Fgx plus vector F. Taking the direction towards the top of the incline as positive, we get vector Frx equals vector F applied minus Fg sine theta minus F. Combining 1 and 2, we get m vector Ax equals vector F applied minus Fg sine theta minus F. Here, the acceleration is 0, since the wheelchair is in equilibrium state, that is, uniform motion. 0 equals vector F applied minus Fg sine theta minus F. Rearranging the terms and substituting the values, we get vector F applied equals Fg sine theta plus F equals mg sine theta plus 50 equals 60 times 9,8 times 1,5 over 10 plus 50 equals 138,2 newtons. The positive sign indicates that the applied force is in the same direction that we assumed is positive. Sipo needs to push the wheelchair with a force of magnitude 138,2 newtons towards the top of the incline in order to move it up at constant velocity.
Starting to feel it? Now go master it with Maski.